Hey explorers! Welcome back to the channel. Today we're diving deep. Literally, we're going to explore the fascinating world of tunnels, those incredible underground passageways that have shaped our world for millennia. But have you ever stopped to think about how they're actually built? From the sweat and toil of ancient civilizations to the cutting-edge technology of today, the story of tunnel construction is truly mind-blowing. We're going to compare the old with the new, the hand-dug with the machine-made. Get ready to be amazed. Welcome to Civil Artifacts. Let's start by rewinding the clock. Imagine a world without electricity, without powerful machines. How did people build tunnels back then? Well, it was all about human ingenuity and sheer hard work. Ancient civilizations like the Egyptians, Romans, and Persians were masters of tunneling. They built tunnels for various purposes: water supply, mining, and even tombs. Take the Khanate system in Persia, for example. These were underground aqueducts that carried water for miles in arid regions, a testament to their incredible engineering skills. The primary tool of the ancient tunnelers was the pickaxe, a simple yet effective tool for breaking rock. They also used hammers, chisels, and wedges. Imagine the sheer manpower required to excavate these tunnels, inch by hand. Ventilation was a major challenge. They used shafts to bring in fresh air and remove smoke from torches. Lighting was provided by torches or oil lamps. It was a dark, dangerous, and incredibly laborious process. Now you might be thinking, that sounds incredibly difficult. And you'd be absolutely right. Ancient tunneling was fraught with challenges. One of the biggest dangers was cave-ins. Without modern support systems, tunnels could collapse, trapping workers. Flooding was another major issue, especially in areas with high water tables. And let's not forget the health risks. Miners often suffered from lung diseases due to inhaling dust and smoke. Despite these challenges, ancient civilizations built some truly remarkable tunnels that stand as testaments to their skill and determination. The Khanate system, which I mentioned earlier, is one of the most famous examples of tunnel from ancient times. It's a sophisticated system of gently sloping underground channels, built to bring groundwater from aquifers in hills and mountains to lower-lying agricultural plains. Estimated it was made in the first millennium BCE. Interesting fact about them, they were constructed entirely by hand, relying on a deep understanding of geology and hydrology. Workers dug vertical shafts at intervals and then connected them with horizontal tunnels. Fast forward to the 19th and 20th centuries. The Industrial Revolution brought about a wave of innovation, transforming tunnel construction forever. The invention of dynamite by Alfred Nobel in the 1860s revolutionized rock blasting. It made it possible to excavate tunnels much faster and more efficiently. The development of compressed air tools further sped up the process. One of the most significant advancements was the development of the tunnel boring machine, TBM. The first TBMs were relatively crude, but they paved the way for the sophisticated machines we use today. All right, let's talk about these modern marvels of engineering. Tunnel boring machines, or TBMs. These massive machines can excavate tunnels through a variety of ground conditions, from soft soil to hard rock. A TBM consists of several key components like the cutter head. This is the rotating front section that breaks up the rock or soil. Different cutter heads are designed for different ground conditions. The gripper shoes. These hydraulic cylinders push against the tunnel walls, providing the force needed to advance the machine. The shield. This protects the machine and workers from cave-ins. The segment erector. This places precast concrete segments to line the tunnel walls. The backup system. This includes systems for ventilation, power, and material transport. TBMs are incredibly efficient. They can excavate tunnels much faster than traditional methods, and they also reduce the risk of cave-ins and other hazards. They are also highly automated, requiring fewer workers. One of the most impressive examples of TBM technology is the Channel Tunnel, which connects England and France. This massive project involved the use of multiple TBMs. It has the longest underwater section of any tunnel in the world, stretching for 37.9 kilometers, 23.5 miles. It was a major feat of engineering with so many interesting facts. You can read more about it if you're a tunnel enthusiast. Anyways, let's continue with the topic. So now let's compare the ancient and modern methods of tunneling. On one hand, we have the incredible ingenuity and sheer hard work of ancient civilizations. On the other hand, we have the cutting-edge technology of modern TBMs. Ancient tunneling was slow, dangerous, and labor-intensive. Modern tunneling is fast, safe, and efficient. However, ancient tunnels were often built with locally available materials, while modern tunnels require vast amounts of resources and energy. What does the future hold for tunneling? Well, we can expect to see even more advanced TBMs, capable of excavating tunnels in even more challenging conditions. We may also see the development of new materials and construction techniques. As our cities continue to grow, tunnels will play an increasingly important role in transportation, water supply, and other infrastructure. So, there you have it, a glimpse into the fascinating world of tunnels. From the ancient picks to the modern machines, the story of tunnel construction is a testament to human ingenuity and our relentless pursuit of progress. If you enjoyed this video, please give it a thumbs up and subscribe to the channel for more exciting content. And don't forget to leave a comment below and let me know what you think. Until next time, keep exploring.